Okay, so 3D Pythagorean Theorem. We talked about this. So we have this rectangular prism. It's a box, right? Except it's rectangular. It has 90-degree angles. That's important. Right? It's a rectangular prism. And we just tried to figure out, and we did figure out, how can you find the diagonal of the box? So not the diagonal of a face, of a flat side, but the diagonal of the box. So from the back right corner through the middle to the front left corner, right? So we're slicing it in half, right? But it's not sliced in half vertically or horizontally. It's from one corner to another corner. Serenity, you're gonna need one of these. And so I challenged you to figure out the length of it, of that diagonal of that rectangular prism. And we found the diagonal, lots of teams found it, and then I told you there were two ways of doing it. So we're gonna talk about both ways of finding that diagonal length. So the most common way involved the base. Do you agree with that? Yeah. Because if you look at the base, the bottom of this rectangular prism, if I found the diagonal of the base, it creates a triangle inside of it. Yes? Because if I find the diagonal of the base, and I'm going to use a highlighter to kind of show what we're talking about. If I find the diagonal of that base, then I have a hidden right triangle. If I find that diagonal, the base hypotenuse, that diagonal inside my rectangular prism becomes the hypotenuse of the interior right angle. And it's kind of an optical illusion. It's one of those things, remember those magic eye posters? I say remember those. Those were popular when I was in elementary school. So,
oh, no wonder.
Right? If you ever are watching Stranger Things, right? Those kids are my age when I was in elementary school. But magic eye posters, they were optical illusions. You had to kind of squint at them to see the optical illusion. So if you kind of blur your vision, you can then see that right triangle coming from the back right corner through the middle to the front left corner. But in order to find the hypotenuse of this right triangle that's hidden, I have to use the hypotenuse of the base of the rectangular prism. I have to find this right triangle, which is down here. Now, I get it. You look at it, and it's not really, this doesn't look like a right angle right here. But I know, because my perspective's off. If I was able to, kind of transport myself into the problem and look at that rectangular prism from the top, if I was able to hover over that and look down at this face, I would know that that would be a perfect rectangle. It's at an angle, it looks like a parallelogram because of perspective. So down here, right here, this is actually a right triangle. Because this bottom piece, even though it doesn't look like it, this bottom piece is a rectangle. So there are two methods to finding the length of the diagonal. The first thing we would do in method number 1 is we would draw the hypotenuse, of the base rectangle. Right? My base of my rectangular prism, if I draw that hypotenuse. Then I'm going to calculate the hypotenuse. So I drew that base, hypotenuse. And now I know that I can figure out that hypotenuse length because my leg is 10 and my other leg is 3. So if I do 10 squared plus 3 squared equals c squared, do you agree? And that's 100 plus 9 equals c squared. And that's 109 equals c squared. Is 109 my answer?
No.
I have to do the square root. So my hypotenuse is 10.44. Yeah? Does that sound familiar? Tochiku, what's your question?
When we did that, I got a slightly different answer, but it was close, so I was
You should have gotten 10.4. I mean, unless you rounded differently.
I didn't round. I didn't.
Well, try it again in your calculator. You might have done 10 squared and 4 squared. It has to be 10 and 3 because 4 is my height. And after I did that, after I calculate that hypotenuse, I can now use 10.44. It's no longer a hypotenuse. 10.44 is now what? It's a leg of the interior triangle. 10.44 is my hypotenuse of my base, but of my interior triangle, 10.44 is not my hypotenuse. 10.44 is a leg. What's the other leg of this interior triangle? This height in front is the same height back here. So after I do that, step 3 is to use the hypotenuse of the base as the leg of the diagonal triangle. You're going to use the hypotenuse of the base. We just found the hypotenuse of the base down here, right? And I put that on there. Well, now I can see, because I drew that diagonal triangle in there, because it's a right triangle, because we're working with the Pythagorean Theorem. So it's, I mean, the Pythagorean Theorem better be used, and the Pythagorean Theorem is used on right triangles, so we better have a right triangle somewhere, right? Now I can use that. It's no longer a hypotenuse, though. I'm going to erase that from my memory, cover it up. That 10.44 is no longer a hypotenuse. It's actually the base, or the leg, of that interior diagonal triangle. And now I'm going to calculate the diagonal hypotenuse. I'm going to calculate the diagonal hypotenuse. And I'm going to do a squared plus b squared equals c squared. And a and b are my legs, and my legs of this triangle are 10.44 and 4. So 10.44 squared plus 4 squared equals c squared. Which is 108.9936. Since it terminates and it's not that big, I'll write the whole thing. Plus 16 equals c squared. How many of you have learned that you can just type this straight into your calculator and get an answer? Good. Those shortcuts are good, right? Like this. 10.44 squared plus 16 squared. If they're together, right? The little button that has an X2 next to the 7. You can even take it one step further. Because I'm solving for the hypotenuse, I simplify even more. I do the square root of 10.44 squared plus 4 squared. Because I know that I'm going to have to square them, add them, and square root them. Gives you the same answer. But here's the deal. If that doesn't make sense to you, don't try to take the shortcut. Because that trick right there, putting it under the square root, taking a squared plus b squared and putting it under a square root only works if you're solving for a hypotenuse. You cannot do that trick. You have to subtract if you're solving for a leg. If you think you discover a shortcut like that, always go back and try it one more time the long way to make sure that your shortcut works, right? Because are there times that a shortcut works, but it only worked that one time because you just got lucky? Yes. So this is 3D Pythagorean Theorem. There is a shortcut to this. And some people figured out the shortcut to this. If you want a shortcut, it's not that much shorter. It maybe saves you 30, 45 seconds, a minute at most. You can figure that out. You can do a little research on your own if you're desperate for a shortcut. It's not that much shorter, but there is an additional way of doing this.